Good morning, everyone. Good morning once again. We started with our quadrilaterals chapter the last time. So we had seen solving problems using congruency of tests. The last thing we were doing was the midpoint theorem, right? So let's quickly revise the midpoint theorem. Before that, I hope you'll have done your homework well and you'll have at least studied all the properties of the quadrilaterals that we have studied. So now we move to one of the most important theorems of your syllabus, which is the midpoint theorem. Okay, students, this theorem is extremely important. You will be applying this theorem even in your 10th standard. So let's see what this theorem talks about. We've already seen this theorem applies to a triangle. So it's a theorem which applies only to a triangle. Now let's see what do we have out here. What does it say? In a triangle, so we have triangle ABC, line segment joining midpoints of any two sides. Students, any two sides, right? So let's consider those two sides as AB and AC. So we need to take midpoints of these two sides, AB and AC. So let's take midpoint of AB. Yes, and we'll take midpoint of side AC. Now, what does the statement say? Line segment joining the midpoints. So let's have a line segment which joins these two midpoints. Yes, what happens with this line segment? Say we call it PQ right now. Okay, so we have P and Q as the midpoints of AB and AC. Since P is the midpoint of AB, we have AP equal to PB. Since Q is the midpoint of AC, we have AQ equal to QC. All right, now what happens? This line segment is then parallel to the third side. Students, which is the third side we are talking about out here? We have already considered AB and AC, right? We have already considered these two sides. So is our third side? Yes. Hello, Pranjal. Yes. So the third side we are talking about is side BC. So what does it say? The line segment, that means line segment PQ, is parallel to the third side BC and half of it. What is the result that we get? PQ is parallel to BC. Yes, PQ is parallel to BC and PQ is also equal to half of BC. That is what the midpoint theorem says. Students, we've already seen this theorem. So once again, let's revise it. Let's see where we will apply this theorem. In any case, whenever you have a triangle, and if there are midpoints of two sides given to you, then you can clearly apply this theorem. And what does the theorem say? Line segment joining the two midpoints is always parallel to the remaining side of the triangle, and it is also half of the remaining side of the triangle, which is the third side. Okay, so like every theorem, we always have a converse. So we'll have a converse of this theorem. Let's look at the converse. We have to start from here today. So let's look at the converse. Now, as we know, converse means exactly opposite, right? In the midpoint theorem, what was given to you? That in a triangle, there are two midpoints of two sides, right? And what you prove is the line segment is parallel to the third side and it is half of third side. Now, what can be the opposite of this? The opposite could be it's given to you that we have a line parallel to one side and we will prove that there is a midpoint of the other side of the triangle. Let's look at the statement. If a line drawn through midpoint of one side of a triangle, so let's look at what the converse says. For one side of the triangle, we have a midpoint. So say for AB, we have taken a midpoint P. Only for one side it is given to us. Next it says that this line drawn through P is going to be parallel to the second side. Since from P we can have a line only parallel to BC, right? So from here we can have a line parallel to BC. So from P we have a line parallel to the second side, which is BC. Then what do we prove? That it bisects the third side. Now the third side that we are talking about is AC, right? So what we need to show is that Q bisects AC. We will prove that Q is the bisector of AC, or we are going to prove that AQ is equal to QC. This is what we get from the converse of midpoint theorem. We understand that there is a midpoint of the third side of a triangle. So what is given to you? For a triangle, we have midpoint of one side, we have a line parallel to the second side, and what do we prove? That the third side is also getting bisected. Yes, so this is what the converse of the midpoint theorem says. Let's quickly look at the sums with respect to these two theorems. Students, the rest of the chapter we're going to solve only using these two theorems, the midpoint theorem and the converse of the midpoint theorem. Let's quickly look at which theorem will be applied where. Now, in triangle ABC, X, Y, Z are the midpoints of sides AB, BC, AC. So students, what do we have? We have a triangle and we have midpoints, right? This given part applies where? To the midpoint theorem, right? Because in a midpoint theorem, we have midpoints of at least two sides of a triangle. So let's do one thing. Let's consider two midpoints at a time. Okay, now what do you need to find, students? XY, YZ, and XZ. What is XZ? XZ is just line joining two midpoints. XY is again line joining two midpoints. YZ is also line joining two midpoints. And what do we know? The line joining two midpoints is always half of the third side. So, but we need to identify the third side properly. So let's do one thing. Let's begin with one thing at a time. So now what we're going to do is we'll consider triangle ABC, and the first thing we are going to consider is AB and BC as two sides of a triangle where we have X and Y as the midpoints. Students, look at side AB. Side AB has midpoint X, right? Side BC has midpoint Y. Now, which is the line segment which joins these two midpoints? XY, right? The line segment which joins points X and Y is XY. Students, XY will be parallel to which third side of the triangle? Come on, let's make this interactive. Let's see if you all have understood the midpoint theorem well. XY has to be parallel to one of the sides. To which side will it be parallel? Line segment XY. Okay, Yugan says AC. What about other students? Yes, come on. XY will be parallel to which third side of the triangle? Okay, others. All right, AC. Thank you so much, Shaizan. Yes, that's perfectly correct, right? What do we understand by parallel lines? That they never intersect. Now, if you look at XY, XY intersects AB and X, XY intersects BC and Y. So, XY can only be parallel to side AC. But right now, we are not concerned about parallel lines, right? What do we want? We need the length of xy. So let's apply the second property of midpoint theorem. Line segment is parallel to the third side and it is also half of the third side. So now students, quickly tell me, if AC is 9, what's the value of xy? It has to be half of AC, right? And yes, it has to be 4.5 centimeters. Yes, so by midpoint theorem, what we understand is that xy will be parallel to AC and half of AC. So xy is 4.5. Students, how do you write this? You have to write it in exactly the same way your midpoint theorem is written. First, we start with what's given. So, in triangle ABC, what do we have? X and Y are the midpoints of AB and BC respectively. Once you understand this is known to you, you have XY will be half of AC as the result of the midpoint theorem. Now, similarly, students, look at line YZ. YZ. What do you have in triangle ABC? Y is the midpoint of BC, Z is the midpoint of AC. So, this line segment YZ will be parallel to, yes students, line segment YZ. YZ is parallel to which line? Come on quickly. I would expect you all to only look at the diagram. Okay, Yugan says AB. That's correct. That's perfectly correct. Thank you so much, Yugan. So if you observe, YZ will be parallel to AB and YZ will be half of AB. Half of 5 is going to be 2.5 centimeters. Similarly, if you look at XZ, now XZ, X is the midpoint of AB, Z is the midpoint of AC. So line XZ has to be parallel to BC and half of BC. Half of 11 is 5.5. That's correct. Thank you so much, Tatvi. Yes, Pranjal. So that is how we apply the midpoint theorem. So this was an extremely easy sum to understand how you apply midpoint theorem. Now from now onwards, we are going to understand how and where we need to apply this theorem. All right. So let's move ahead. Let's look at the next sum. Now pay attention. We start with the proving sums. ABCD is a rhombus. We have ABCD as a rhombus and PQRS are the midpoints of sides AB, BC, CD and AD. So students pay attention. P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD and same way S is the midpoint of AD. We need to show that this figure which is formed by joining the midpoints is a rectangle. We need to show that PQRS is a rectangle. Now, students, if you pay attention, we have midpoints. Most important part of this sum is that we have midpoints in this sum. Now, whenever you have midpoints, we can apply midpoint theorem, right? For applying midpoint theorem, we need a minimum of two midpoints, right? So to apply midpoint theorem, we need at least two midpoints, but we have four. So let's see if we can apply the midpoint theorem. Now, to apply the midpoint theorem, students, we have the first construction out here. We need triangles, so we have joined one diagonal AC. We have joined diagonal AC of the rhombus. Now our rhombus has been divided into two triangles. And students, pay attention. Look at this highlighted pink triangle. If I look at this triangle, I have P as the midpoint of AB given to me, Q as the midpoint of BC also given. So can we apply the midpoint theorem? Yes, obviously we can apply the midpoint theorem. And what do we get? This line segment PQ, which is formed by joining the midpoints, will always be parallel to AC, and it will also be half of AC. Students, yes, PQ is parallel to AC, PQ is half of AC. This is what we understand by midpoint theorem. Now, students, if you pay attention, to prove that PQRS is a rectangle, first thing we are going to prove that PQRS is a parallelogram. And next, once we get PQRS as a parallelogram, we just need to prove one angle to be 90 degrees. Yes, what is a rectangle? Basic definition of a rectangle says all angles 90. So we just need to prove one angle as 90 degrees. Once this is a parallelogram and we have one angle 90, we know opposite angles of a parallelogram are equal. So if S is 90, Q will be 90. We also know adjacent angles of a parallelogram are supplementary. So P and S are adjacent angles. So if S is 90, P also has to be 90, because 90 plus 90 is 180. And if P is 90, R is the opposite angle, and that is also 90. So once this figure becomes a parallelogram, we just need to prove one angle to be 90 degrees. Yes, we won't waste time proving P, Q, R, S all 90. Okay, so let's see how can we prove this figure to be a parallelogram. Students, for a figure to be a parallelogram, we need opposite sides parallel to each other and opposite sides congruent to each other as well. So let's see if we can achieve that using midpoint theorem. Let's see. Yes, that's correct. Okay, PQ equal to SR. All right, let's see. Now what do we have? P and Q as the midpoints of AB and BC. So what do we get? We have already achieved this result. PQ is parallel to AC, PQ is half of AC. Similarly, students, in this green triangle, in triangle ADC, can we apply the midpoint theorem? Quickly, now students, I want you all to apply the midpoint theorem in triangle ADC and give me what we will obtain from this triangle. What is the result of the midpoint theorem from this triangle? What do we know about SR? Come on, students, quickly tell me. What do we know about SR from this triangle? Can I apply midpoint theorem on triangle ADC? Yes, students, quick. Pay attention. In triangle ADC, check. Do we have midpoints? Yes, we have S, which is the midpoint of AD. That's correct, Tatvi. Yes, perfect. And we have R, which is the midpoint of DC. We have two midpoints. We have a triangle. Best, right? We can apply the midpoint theorem so very well. So what can we do? We have SR, which is going to be parallel to AC. And we also know that SR is going to be half of AC. So SR parallel to AC, and SR is half of AC. Let me number this as equation 3 and 4. Yes, equations 3 and 4. Now students, pay attention. Look at equation 1 and equation 3. Yes, students, what do you observe in equation 1 and equation 3? The right hand side of both the equations are equal. PQ parallel to AC and SR also parallel to AC. So can I say that PQ is parallel to SR? Yes, students, we have seen this, right, in Euclid's theorem. Yes, what does Euclid say? If one thing is parallel to another, and if the second thing is also parallel to the same thing, then they are parallel to each other. PQ and SR are now parallel to each other. Students, pay attention. PQ and SR are two sides of our quadrilateral, which has to be a rectangle. So we have got PQ parallel to SR. Now look at equation 2 and 4. Equations 2 and 4. Again, what does the right hand side say? half of AC, half of AC. That means again right hand sides are equal. So now what do we get? PQ half of AC, SR half of AC. Therefore, PQ is equal to SR. Yes, since the right hand sides are equal, left hand sides have to be equal. Students, now pay attention. Two sides, one pair of opposite sides of a quadrilateral, if they are parallel and if they are equal, can I safely say that it is a parallelogram? Yes, obviously, that is exactly what the property of a parallelogram is. What does it say? PQRS is a parallelogram because a quadrilateral becomes a parallelogram if one pair of opposite sides is parallel and equal. Students, if only one pair of opposite sides is both parallel and equal, then I can say it is a parallelogram. Now, it doesn't stop there. We have achieved one level, right? We have proven that PQRS is a parallelogram. Now, somehow, I need to prove that angle S is 90 degrees. So now, students, we are going to focus on angle S. Now, students, pay attention. First thing, before looking at angle S, students, quickly tell me, what do we know about diagonals of a rhombus? Quick, what is that important property of diagonals of a rhombus? Quickly, let me see who's done their homework well. Diagonals of a rhombus, what do we know about them? Some special property. Okay, they bisect at 90. Yes, Shazan, that's correct. Only diagonals of a rhombus bisect at 90. Since a square is also a rhombus, diagonals of a square are also perpendicular to each other. Yes. So what can I say? Diagonals of a rhombus are perpendicular bisectors of each other, right? They're perpendicular and they bisect. That means I already know that this angle, okay, I'm going to change my color so that it's clearly visible. Let me take a red. Okay, so what I already know is angle DOA is 90, right, students? Because BD and AC are the diagonals of a rhombus, so I already know that this angle is 90 degrees. Now, students, observe the figure that I give you. So I am going to talk about SMO and say this is Z. Okay, so say this is letter Z, SMOZ. Look at this quadrilateral, small quadrilateral SMOZ. If I prove this quadrilateral to be a parallelogram, students, pay attention. Try to understand what we are doing out here. Quadrilateral SMOZ. If I prove this to be a parallelogram, I already have angle O to be 90 degrees. So, if it becomes a parallelogram, will angle S also be 90 degrees? Yes, by which property of the parallelogram will angle S also be equal to 90? Come on, students, tell me. If this SMOZ is a parallelogram, if I prove it to be a parallelogram, then by which property angle S is going to be 90 degrees? We already know angle O is 90. Yes, students, come on. What is that property of a parallelogram? If O is 90, how can S also be 90? Angle S be 90 degrees. Yes, students, if you're not able to understand my question, I can repeat that once again. Or if you're thinking, come on, quick. I want to know if SMOZ becomes a parallelogram and angle O of this parallelogram is 90, what is the measure of angle S? And by which property will you get it? Which property of a parallelogram will you get it? Okay, opposite angles. Yes, Pranjal, that's perfect. Opposite angles of a parallelogram, students, are equal. We already know that. So since O is 90, S becomes 90 if SMOZ becomes a parallelogram. That means now we are going to prove that SMOZ is a parallelogram. Students, pay attention. So we are going to focus on SMOZ. If you look at SMOZ, we already know that SR is parallel to PQ. Yes, students, what we know is SR is parallel to PQ. Now, so SR is parallel to PQ. Can I say instead of SR, can I call it SM? Yes, obviously SM is a part of SR. Instead of OA or instead of basically PQ, can I say, okay, now students, SR is parallel to AT, right? So what I'm going to do is, let's mark this as Z. Since SR is parallel to AC from our midpoint theorem, I'm going to say SM is parallel to OZ. Anyone who has not understood this, if SR is parallel to AC, we already know that small parts of SR is parallel to small part of AC. Yes, that's correct. So now all I need to prove is that SZ parallel to MO. We need to prove SZ parallel to MO. Let's again apply the midpoint theorem, students. Look at this highlighted triangle ADB now. What do we have? S is the midpoint of AD, P is the midpoint of AB. We have midpoints of two sides of a triangle. So can I say SP is parallel to DB and SP is half of DB? Students, SP parallel to DB and SP is half of DB. But we don't want half of DB. So let's only look at SP parallel to DB. Now, if SP is parallel to DB, can I say SN is parallel to MO? Yes, students, a part of SP is SN and a part of DB is MO. So I can say SN parallel to MO. Now, students, pay attention. What did we have? We had, we already have SM and ON parallel to each other. Now we also got SN parallel to MO. So we have got the other pair of opposite sides also parallel to each other. So now can I say that SMON is a parallelogram? Yes, students, I can say SMON is a parallelogram. So let's quickly look at that. What do we have? Yes. So now I have SMON to be a parallelogram by definition. What does the definition say? In a quadrilateral, if opposite sides of a quadrilateral are parallel, then the quadrilateral becomes a parallelogram. Now, students, it's so easy. What do we have? Angle MSN equal to angle MON. Opposite angles of a parallelogram are equal. But we know MON is 90 degrees because we have already discussed diagonals are perpendicular bisectors of each other. Diagonals of a rhombus are perpendicular bisectors of each other. Hence, from these two steps, what do we understand? Angle MSN is also equal to 90 degrees. Yes, students, what do we get? MSN equal to 90 degrees. Angle S is 90. Now, in a parallelogram, if one angle is 90, then all angles are a right angle and hence it becomes a rectangle. So I hope you all have understood this sum. Let's brush up the concept once again. To prove PQRS to be a rectangle, what did we do? We first proved that it is a parallelogram and then we proved that any one angle of this parallelogram is a right angle. Once you get one angle to be 90 degrees, all angles are going to be 90 and it has to be a rectangle. So this is how we will approach sums when you have to prove them to be a rectangle. Anyone has any doubts with this sum? Else we'll be proceeding ahead. Anyone, any doubts? Okay, no doubts. All right, okay. Okay, students. So now let's move to the next sum. We have clearly understood how to use the midpoint theorem. So now we will be doing it properly and by ourselves in the next sums. Okay, pay attention. Show that line segments joining midpoints of opposite sides of a quadrilateral bisect each other. Let's see, what do we have? First thing what we understand is we have a quadrilateral. So what do we have? We have quadrilateral ABCD. Yes, that is what is given to us in the figure, quadrilateral ABCD. Now, what does it say? Midpoints of opposite sides of quadrilateral. That means AD and BC. We have taken midpoint S and Q as midpoints of AD and BC, and there is a line segment joining the midpoints. So we have joined S to Q and similarly P to R. This is how you understand how to draw the diagram if it's not given to you. We have a quadrilateral, then we have taken midpoints of opposite sides and we have joined them with a line segment. So what do we need to prove? We need to prove that the line segments, when they are joined, we need to prove that the quadrilateral, okay. So show that the line segments joining the midpoints of opposite sides of the quadrilateral bisect each other. Now, students, pay attention. What we need to show is that these line segments bisect each other. Means what? I need to show that if I take SQ, I need to show that SQ is getting bisected. That means SO equal to OQ. Also, what do I need to show? PR is also getting bisected. That means we also need to prove PO equal to OR. Yes, students. So this is what we need to prove. I need to prove that SO equal to OQ, PO equal to OR. Now, students, pay attention. Basically, if I join SR, so students, pay attention to what I'm doing. I'm going to join SR, RQ, PQ, and SP. If I join SR, RQ, PQ, SP, what happens? There's a quadrilateral formed, right? SRQP. There is a quadrilateral formed SRQP. And students, what are PR and SQ? PR and SQ become diagonals of this quadrilateral SRQP. Now, if I need to show diagonals of a quadrilateral bisect each other, then what is that quadrilateral called? Students, if diagonals of some quadrilateral bisect each other, then what is the special name of that quadrilateral? What is it? Is it a parallelogram, rectangle, square, rhombus, trapezium? What does it become? If diagonals bisect each other. Okay, diagonals bisect each other, it becomes a rhombus. That's correct, you can't. But we have another special property for a rhombus, that diagonals are perpendicular bisectors of each other. Do we need that? No. So what's the basic figure in which diagonals only bisect each other? Basic figure. Okay, Tatvi says parallelogram. Yes, Tatvi, that's correct. So in a parallelogram as well, diagonals bisect each other. Yes, you can't. So we know a rhombus is already a parallelogram. But proving this a parallelogram will be much easier than proving it to be a rhombus, right? So if I now prove SRQP, students look at SRQP. If I prove this to be a parallelogram, automatically PR and SQ become the diagonals of this parallelogram, and they have to bisect each other, right? Then PR and SQ have to bisect each other because SRQP becomes a parallelogram. So what is the hint to this sum? We will prove SRQP is a parallelogram. Yes, students. So this is the hint to the sum. Now let's start working on this. Now, again, for SRQB to be a parallelogram and we have midpoints out here, that means we can apply the midpoint theorem. Students, if you have midpoints, you can apply the midpoint theorem. But for that, I need triangles. Let's see what kind of triangle, not just any random triangle. I need triangles such that I will get sides to be parallel to each other, right? I need a triangle in which PQ becomes parallel to a side. So let's do one thing. We will again, just like the previous sum, draw a simple construction. We are going to now join diagonal AC. Simple construction, just like the previous sum, draw diagonal AC. Now, students, if you pay attention, in triangle ADB, what do I have? P is the midpoint of AB, Q is the midpoint of BC. So simple. Can I apply the midpoint theorem? Obviously. What do we get? PQ parallel to AC and PQ is half of AC. Yes, students, what do I get from this? PQ parallel to AC and PQ half of AC. So this is the first result from midpoint theorem in this triangle. Similarly, can I apply midpoint theorem in triangle ADC? Now, students, in triangle ADC, you will apply the midpoint theorem for me and quickly give me the result. Check where we have the midpoints, which two sides have midpoints, and which is the third side. How do we have parallel sides? Please check that and let me know in triangle ADC, how can you apply the midpoint theorem? Come on, quick. Okay, Tatvi says SR parallel to AC. Pranjal says SR half of AC. Okay, both of y'all are perfectly correct. Yes, Yugant, SR is half of AC. So let's use both the results, right? Midpoint theorem gives you two things at a time. That's so nice, right? From one thing, you get two results. So let's do one thing. What do I understand? SR is parallel to AC and SR is half of AC. Students, if you pay attention, these are repeat steps from the previous sum. We had already done these steps, right? We had equations 1, 2, 3, 4, and then we had also seen, if you look at equation 1 and 3, look at equation 1 and 3, students, what do we get? PQ parallel to AC, SR parallel to AC. So can I say PQ parallel to SR? Yes, obviously we can say that from 1 and 3. Same way, PQ half of AC, SR half of AC. Again, right hand sides are equal. So what do I get? PQ is also equal to SR. PQ is also equal to SR. Now, students, pay attention. In quadrilateral PQSR, what do I have? One pair of opposite sides are parallel and one pair of opposite sides are equal to each other. So that's it. Our work is done, right? If a pair of opposite sides are parallel and equal to each other, we already know by definition it becomes a parallelogram. So this is what we have done. We have done all of this, and what do we know? If a pair of opposite sides is parallel and equal, it becomes a parallelogram. And once PQRS is a parallelogram, PR and QS, which are the diagonals of the parallelogram, have to bisect each other. So there we go. At the start, we had said we need to prove this, and we have achieved this. Yes, what do we get? OP equal to OR, OS equal to OQ, hence proved. Yes, students, is that understood? So simple it becomes using midpoint theorem. Anyone, any doubts with this sum? Any problem with this sum? Kuch nahi samjha hai, ma'am. You want me to repeat some part again? I can do it for you. So it's always Yugant who says there's no problem. So I believe others have understood or there's some problem. Others, everything cool? Everything's going great? Then we can move to the next sum. All right, let's quickly move to the next sum then. Now, now students pay attention. You need to check for the midpoints well and take one triangle at a time and apply midpoint theorem, because now we're going to have more than one triangles. Yes, we will have overlapping triangles. Let's see what the sum says first. In the figure, point X is the midpoint of side BC. Students, pay attention. As soon as you get something which is important in the sum, mark it in your diagram. X is the midpoint of BC. That means what? XB and XC are equal to each other. Yes, I'm also going to write that. That means I know XB is equal to XC. Yes, I know that because X is the midpoint of BC. What else do we know? Segment XZ is drawn parallel to side AB. So if you look at XZ, it has this arrow, right, going up. That's the parallel sign. And the same sign is there on AB, which shows that XZ and AB are parallel to each other. Okay, all right. Students, so we have one midpoint and one pair of parallel sides, right? Okay, so let's see which theorem we can apply. Also, we have segment YZ parallel to AX. Look at YZ and AX. They have the same down arrows. That shows that YZ is parallel to AX. Now, prove that YC is 1/4 of BC. Prove YC is 1/4 of BC. Now, students, we have no theorem in which directly we get the result as 1/4 of a side. So we will leave this for some time and we will focus on what is given to us. Now, first thing, from the given information, we have one midpoint and one parallel side. Which theorem can we apply, students? Midpoint or converse? Come on, converse or midpoint? Which theorem can we apply? Can we apply the midpoint theorem? Or we'll have to apply the converse theorem now? What do you all think? Yes, if you all have paid attention to the details of these two theorems, you all will know. Midpoint or converse? Can I apply the midpoint theorem or should I try to apply the converse of the midpoint theorem? What do you all think? Come on, I want answers from everyone right now. Before that, we cannot proceed, people, because you all need to understand both the theorems really well. Can I use the midpoint theorem or the converse of midpoint theorem? I have midpoint of only one side of a triangle, and then I have line parallel to another side of the triangle. So can I apply midpoint theorem, students? All right, one thing at a time. How many of you all feel I can apply the midpoint theorem? Yes or no? Okay, Yugant says no. No, we cannot apply midpoint theorem. All right. What do others think? No. Arya says no. Yes, students, we cannot apply the midpoint theorem. Midpoint theorem has a basic criteria that we need at least two midpoints. And we do not have two midpoints, right? So we have just one midpoint. So now let's apply the converse of midpoint theorem. Look at one triangle at a time. We have X as the midpoint of BC. Yes. So we are going to consider the triangle in which BC is the side of the triangle. Now, students, BC is the side of which triangle? Only for triangle ABC. Yes, since X is the midpoint of BC, we will have to consider BC as one of the sides. That means we have to now start considering triangle ABC. Now, if you look at triangle ABC, students, what do you have? Yes, students, what do we have? X is the midpoint of BC, and from this X, we have a line parallel to the second side AB of the triangle. Yes, students, what do we have? X is the midpoint of BC, and from X, we have a line parallel to second side AB of a triangle. Then by converse of midpoint theorem, we know that this line XZ will also bisect the third side. That means Z is the midpoint of AC. Now we understand that Z becomes the midpoint of AC. So Can I mark this? Yes, Z is the midpoint of AC, so I'm going to say AZ is equal to ZC. This is what we understand. What I understand is AZ is equal to ZC. Now, students, pay attention. But that doesn't solve our problem, right? We need to go to YC. Now look, where do we have YC? YC is in what part of the triangle? Is it in triangle AXC? Yes, it is in triangle AXC. And in this triangle now, students, pay attention to what we have. Students, in this triangle, Z is the midpoint of AC. Yes, we got this from the first result. Also, it's given to us that from this Z, we have a line parallel to the second side AX of our triangle AXC. Now, students, we are considering triangle AXC. So, YZ is parallel to AX and Z is the midpoint of AC. So, clearly, by converse of midpoint theorem, now I can say Y is the midpoint of XC. Yes, students, obviously I can say that by converse of midpoint theorem, Y is the midpoint of XC. Once I know that Y is the midpoint of AC, since we need the result for Y, what we are going to do is YC. We're going to say YC is going to be half of XC. Yes, since Y is the midpoint of XC, YC is half of XC. But students, look at XC. What do we know about XC and BC? Students, can I say XC is also half of BC? Yes, obviously we know X is the midpoint of BC. So isn't XC half of BC? So now instead of XC, can I put half BC? Yes, let's see what happens. So now YC is half of. Instead of XC, I'm now going to put half BC. So into half BC. And what does this become? Half into half is 1 upon 4. 1 upon 2 into 1 upon 2 is 1 upon 4 BC. Yes, what do I get? YC is 1/4 of BC. Yes, so first you need to apply all the theorems that you know. Apply the theorem that you know which can be applied and then come to the result that is desired. YC is 1/4 of BC. Yes, students, anyone, any doubts with this sum, anything that's not understood? I'm sure now you'll have started getting how to apply the midpoint theorem in any sum, right? Let's quickly move to the next sum and try and see if y'all can do that. Let's see. All right, so we're done with this. Okay. Now the next sum. Next sum is extremely easy, students. Pay attention. What do we know? ABCD is a trapezium in which AB parallel to CD. Students, even if they had not given you AB parallel to CD, we know a trapezium is a quadrilateral in which only two sides or one pair of opposite sides are parallel to each other. That means clearly in the figure AB and CD should be parallel to each other. Next, what do we have? BD is a diagonal and E is the midpoint of AD. Students, it's given to us that E is the midpoint of AD. All right, okay. Next, a line is drawn through E parallel to AB and intersecting BC at F. Students, pay attention. From E, we have drawn a line parallel to AB. So, EF is parallel to AB and it intersects BC at point F. Show that F is the midpoint of BC. Students, first thing now, look at what you need to prove. We need to prove that F is the midpoint of BC. Students, to prove that any point is the midpoint of side of a triangle, we can only apply converse of the midpoint theorem. Yes, because converse of midpoint theorem says that, what does it say? If a line passing through the midpoint of one side of a triangle is parallel to the second side, then it bisects the third side. Now, from the given information, let's start collecting all the things that we know. First thing that we know is AB is parallel to CD, opposite sides of a trapezium. What else have they said? Line is drawn through E parallel to AB. That means EF is also parallel to AB. Yes, EF is also parallel to AB. And obviously, what we understand is that CD and EF are parallel to each other. That means CD parallel to EF, also parallel to AB. We have three lines which are parallel to each other. Next, now students, pay attention. Let's take one triangle at a time and start applying the midpoint theorem. So let's quickly observe. In this triangle, what do we have? It's given E is the midpoint of AD. Next, we already know EF is parallel to AB. So can I say EG is parallel to AB? Yes. Can I say EG and AB are parallel to each other? EG is a part of EF. So yes, definitely I can say that. Now students, what do we get? Yes. E is the midpoint of AD, EG parallel to AB. So by converse of midpoint theorem, the line also bisects the third side BD of triangle ADB. Yes, G is also the midpoint of DB by converse of midpoint theorem. In the same way, students, now since G is the midpoint of BD, I'm going to mark DG and BD equal. Now look at triangle BCD. In the same way, can I prove that F is the midpoint of BC, students? Let's try to do it. Now, in triangle BCD, let's see what do we have. In this triangle, DG is congruent to BG. Yes, DG is congruent to BG. That means G is the midpoint of BD. What else do we have? Can I say GF is parallel to DC? Yes, obviously. We know that EF is parallel to DC. So GF is a part of EF. So GF is also parallel to DC. Now, again, in a triangle, we have midpoint of one side. We have a line parallel to the second side. So obviously, the third side is also getting bisected. That means F is also the midpoint of BC by converse of BPT. Yes, what do we have? G is the midpoint of DB. GF is parallel to DC. Once you have these two things given, F becomes the midpoint of the third side. Yes, what do we understand? F becomes the midpoint of BC by converse of midpoint theorem. Is that understood, students? So we have to just keep on applying this property again and again till you achieve the desired result. All right. Let's quickly look at the next sum now. All right. Let's see. What do we have out here? PQRS is a parallelogram. Okay. In which A is the midpoint of side SR. Again, we have one midpoint A. Next, B is the point of on diagonal PR such that RB is 1/4 of PR. Students, let's see why we have been given this information. RB is equal to 1/4 of PR. Now, let's see from this if we can achieve something. Students, what do we know about diagonals of a parallelogram? Come on, quick. This is a parallelogram, right? PQRS is a parallelogram and RP or PR is the diagonal of a parallelogram. So what do we know about diagonals of a parallelogram? Yes, quick students. Now you need to understand how to attack any given problem. So let's quickly see. They have given us this information, right? This information cannot be used directly in any theorem. Yes, is that correct? 1/4 of PR is not an information or it's not a result in any theorem. So let's see why we have been given this. Yes, they bisect each other. Yes, that's perfect, Arya. Diagonals of a parallelogram bisect each other. So if I look at diagonal PR is bisected into two parts, PO and OR. Yes, PO and OR. So students, can I say that PR is equal to twice OR? Yes, obviously, right? PR is going to be double of OR. PR is also going to be double of PO, but right now we don't need PO. So can I say PR is twice OR? Yes, I can. Let's try to substitute this value of PR in our equation. RB is 1/4 of PR. Let's try to do that. So now what do I get? RB becomes 1 upon 4 into PR can be written as 2OR. So I'm going to write 2OR. Can I cancel 2 and 4? Yes, obviously 2 ones are 2 twos are. And now what do I get? RB is half of OR. Students, now does it make any sense? If RB is half of OR, that means RB should be equal to OB, right? If RB is half of OR, RB and OB should be equal to each other. That means B is actually the midpoint of OR. What we have achieved from this important information is that we don't have one midpoint. A is already the midpoint, but we also have B as the midpoint of OR. Is this understood? So any information which is given to you, check if it is a part of any theorem. If not, you need to derive something from that. So now with this information, let's proceed ahead. So now from this information, What we know is that B is the midpoint of OR. Now, A is the midpoint of RS, B is the midpoint of OR. So, which triangle should I consider? To apply midpoint theorem, which triangle should I actually consider? Yes, I obviously need to consider a triangle in which RS and OR are two sides of that triangle. Yes, students, obviously, that is when I will be able to use the properties of A and B as midpoints. Now, students, let's move to the rest of the sum. First, let's try to understand what do we actually need to prove. Now, also, AB when produced meets QR at C. All right, we are extending AB to a point C on QR. We need to show that C is the midpoint of QR. We need to show C is the midpoint of QR. Now, students, pay attention. If you look at QR, C is the midpoint of QR. QR is side of which triangle? Yes, I can say QR belongs to triangle RSQ. Yes, students. Can I say QR? Yes, converse of MPT. Yes, converse of the midpoint theorem. That's correct. We will have to apply that. Look at this triangle, students. RSQ. In this triangle, if I need C to be the midpoint of RQ, what are the ingredients that I require? For any point to be a midpoint of the third side, I need two things. Yes, midpoint theorem needs two things given to us. What do we need? First, we need A as the midpoint of first side. Do we already have that? Yes, A is the midpoint of RS. That thing is done. So one tick. Next, what else do we know? From A, we need a line which is AC to be parallel to the second side SQ. So now if you look at the hint, what does the hint say? The hint says prove AC equal to SQ. Why does the hint say that? Because once AC is equal to SQ, by converse of midpoint theorem, C will automatically become the midpoint of RQ. Yes, so now we are going to focus on only proving AC parallel to SQ. For that, let's use the information that we have just now collected. We already saw that B becomes the midpoint of OB. Sorry, B becomes the midpoint of OR. So can I say OB equal to OR? Yes, obviously. Let me apply midpoint theorem on the small triangle RSO, where I know that A is the midpoint of SR. So A is the midpoint of SR and B is the midpoint of, okay, so please understand the arrows show midpoint, okay? So B is the midpoint of OR. So in triangle RSO, A is the midpoint of SR, B is the midpoint of OR. We have two midpoints. Can I say AB parallel to SO? Yes, students, obviously I can say AB parallel to SO by midpoint theorem. I'm writing MPT. This happens from the midpoint theorem. Now, if you look at AB, I'm sure AB can be written as AC, right? Because it's the same line. Also, SO can be written as SQ because it is the same line. So now I can achieve this AC parallel to SQ. Once you get this, students, it becomes so easy, right? Now, what do we have? In our bigger triangle RSQ, students, yes, what do we have in triangle RSQ? A is the midpoint of RS. AC parallel to SQ. Yes, what do we have? A is the midpoint of RS. AC parallel to SQ. So can I say that C is the midpoint of side QR? C is the midpoint of third side QR by converse of MPT, by converse of the midpoint theorem. That's how we achieve this sum. Yes, anyone, any doubts with this sum? Students, so pay attention whenever, one small hint, whenever you have a quadrilateral. And why quadrilateral? Because in a quadrilateral you can draw a diagonal and convert it into triangle, right? So you will have triangles. If there is something about midpoints given to you, and if you need parallel lines, then the best theorem to use is midpoint theorem. Yes, students, again, what did I say? One, you need to have midpoint. Yes, midpoint, either one or two midpoints. If you have two midpoints, you can use the midpoint theorem. If you have one midpoint, you can use the converse of the midpoint theorem. Yes, you can use the converse of the midpoint theorem. And which is the other thing, you need at least one line parallel to one side of a triangle. Yes, what do you need? You need a line parallel to a side of the triangle. If these two things are given or one thing is given and one thing you have to prove, you can go ahead and use the midpoint theorem. Yes, I hope this is understood. Let's go ahead and look at the further sums now. Okay. Now, the most important theorem, like I said, and the most important proof of the theorem as well. Students, both the midpoint theorem and, when I say that, proofs of the midpoint theorem and converse of the midpoint theorem are extremely important from the point of view of exams. You will, in most cases, surely get to prove one of these theorems. So let's try to prove the midpoint theorem. We have already seen sums on the midpoint theorem. We have seen how to apply it. Now we will see how do we prove this theorem. So again, let's quickly go through the statement. What does the statement say? In a triangle, line segment joining midpoints of any two sides. So we have triangle ABC. Let's consider those two sides to be AB and AC. So we are going to take midpoints of sides AB and AC. Quickly, I have taken P as the midpoint of AB, Q as the midpoint of AC. So in a triangle, if we have line joining two midpoints, then what happens? What do I need to prove? I need to prove that this line PQ is parallel to the third side BC. Pay attention, students. Third side, BC is the third side, and PQ is also half of BC, half of the third side. Now, we need to prove two results, so we will prove one result at a time, or let's see what we can do with this. Now, students, if you pay attention, first thing, forget the first part, look at the second part. For the second part, we need PQ to be half of BC. Now, if there is no information given to you, or from the given information, how are you going to find if PQ is half of BC? That's not possible. So let's first do a small activity to understand how do we get segments and half of those segments, right? So we need some construction. Before that, we will look at an activity. Students, pay attention. What do you see out here? We see segment AB, and what we understand is AC is equal to CB. That means C is the midpoint of AB. Yes. Now, for C to be the midpoint of AB, what we understand is AC is equal to BC. And what is the relation of AC and BC with AB? Yes, students, what is the relation of AC and BC with AB? Yes. What's the relation between AC and AB? Yes, students, what do you think? What's the relation between AC and AB in terms of length? Yes, students? Are AC and AB equal, or AC is half of AB, double of AB? What is it? What do you think it is? Half of AB. Yes, Arya, that's correct. Since AC and BC are equal, AC and BC both are equal to half of AB. That means, what do you understand? If you need one segment to be half of another segment, one, it needs to be part of that same segment. Yes, if AC has to be half of AB, AC has to be a part of AB. So now, students, we are going to have a similar construction. If PQ has to be a half of some segment BC, first thing, PQ needs to be half of a segment. Yes, PQ has to be half of a segment of which PQ is a part. PQ has to be a part of that segment. So look at the construction. Now, students, we need a construction. PQ, if you observe out here, is not a part of BC. So then let's do one thing. Let's make PQ a part of another segment and half of that. How can we achieve that? What I can do is I can extend PQ. Say I can extend PQ to a point, say R, such that PQ is equal to QR. Yes, can I have such a construction? If PQ is equal to QR, then automatically PQ becomes half of PR. Yes, so what does the construction say? Extend PQ to a point R such that PQ equal to QR. That means PQ is half of PR. Now let's join the rest of the figure. So I'm going to join RC. Now students, from our construction, I already know that PQ is half of PR. Yes, students, we already know PQ is half of PR, but I want PQ to be half of BC. Yes, If I get PR equal to BC, students pay attention. If I get PR equal to BC, then can I replace PR with BC? Yes, obviously. If I get PR equal to BC, then PQ is half of PR. PQ will also be half of BC. That means what do we want? We want PR to be equal to BC. Yes, that's the first part that we are going to prove, students. So I'm writing the hint out here. Hint is we will prove PR equal to BC. Now let's move to the first part of the sum that we need to prove. We also need to prove PQ parallel to BC. Students, look at PQ and look at BC. If I want PQ parallel to BC, PQ is a part of PR. So can I say actually I need PR parallel to BC? Yes, obviously students, PQ is a part of PR. So if I want PQ parallel to BC, I actually want PR parallel to BC, right? Now, look at quadrilateral PRBC. Yes, students, look at quadrilateral PRBC. In this quadrilateral, I want one pair of opposite sides equal to each other. That means PR and BC equal to each other. And I also want same pair of opposite sides to be parallel to each other. Yes, PR parallel to BC. That means I need to prove that PRBC is a parallelogram. Yes, students, a pair of opposite sides parallel and equal to each other. That means it should be a parallelogram. Now, from our construction, let's start achieving what we need. Come on. Now, let's quickly move to the proof of this theorem. Let's quickly try to get one thing at a time. I need to prove PRBC, PRCB as a parallelogram. So now let's start proving one thing at a time. Students, first thing what we're going to do is, we have seen our construction. Take a point R on ray PQ such that PQR, P dash Q dash R, all this means is that PQ and R are in the same straight line and PQ is equal to QR. You have already seen that, and we have joined CR, the remaining part. Let's start with the proof. Let's start with the proof of this. Now, students, if you observe, we need PRCB to be a parallelogram. So let's see what we'll do one thing at a time. Students, look at triangle APQ and triangle CQR. APQ and CQR. Quickly, what do we have? In these two triangles, we already know Q is the midpoint of AC. That means AQ equal to QC. We're going to prove these two triangles congruent, yeah? So pay attention. AQ equal to QC. Next, what do I know? From construction, we already know that PQ is equal to QR. Yes, because that was our construction. And angle PQA is congruent to angle CQR. Yes, PQA is congruent to angle CQR, vertically opposite angles. So can I say AQP congruent to CQR? Yes, definitely. By SAS criteria or by SAS test, the two triangles are congruent. But why did we do that? Now students pay attention. First thing, for PRCB to be a parallelogram, students pay attention, I need to get PB equal to CR and PB parallel to CR. Once PB is equal to CR, PB is parallel to CR, PBCR will become a parallelogram. So pay attention, how are we going to do that? Now, once these two triangles are congruent, PAQ is congruent to QCR. Look at PAQ and QCR. Yes, PAQ congruent to QCR. Students, look at lines AP and CR and look at these angles A and C. What kind of angles are being formed? Come on, quickly. What kind of angles are being formed? Which letter do you see out here? Yes, which letter is being formed out here? And these two angles are what form of angles? Yes, students, what are these two angles? Angle PAQ and QCR. Observe the letter that is being formed. Yes, which letter is being formed? The letter Z. Yes, the letter Z is being formed. And what do we know about angles within the letter Z? Yes, Dishita, what do we know about angles within the letter Z? Come on. Yes? What are the angles in the letter Z, students? Come on. You need to remember your lines and angles chapter well. These are alternate angles. Yes, very good, Arya. We have a pair of alternate angles. And if alternate angles are equal, what we understand is that AP is parallel to CR. Yes, we have got AP parallel to CR by alternate angles test. Yes, by alternate angles test. Now, if AP is parallel to CR, I can also say AB is parallel to CR. Yes, because AP is a part of AB. Or I can also say PB parallel to CR. Students, pay attention. PB parallel to CR. We have got one pair of opposite sides of the quadrilateral parallel. We have got PB parallel to CR. Now we are going to prove PB also congruent to CR. Let's see how do we do that. So from the same triangle, students, pay attention. Once triangle APQ is congruent to QCR, the same two triangles, can I also say AP is equal to CR? Yes, look at AP and CR. Yes, they are just corresponding sides of congruent triangles. So if AP is equal to CR, AP is equal to PB. That's given to us because P is the midpoint of AB. Now, look at statement number 2 and statement number 3. AP equal to CR, AP equal to PB. So can I say PB is equal to CR? Yes, obviously. Now students, pay attention. Look at the steps that I'm highlighting. PB parallel to CR, PB equal to CR. What do we have? In a quadrilateral, one pair of opposite sides are parallel and equal. Therefore, PBCR becomes a parallelogram. Yes, a quadrilateral is a parallelogram if one pair of opposite sides is parallel and equal. We have seen this innumerable times during the sums, right? So we already know this. Now, once this becomes a parallelogram, students, it's so easy. I can say that the other two sides of the parallelogram, that is PR and BC, will be parallel to each other. PR parallel to BC. We have already seen that this is what we need to achieve. But instead of PR, I can write PQ, right? Because PQ is a part of PR. That gives us the first thing we needed. PQ parallel to BC. Next, we needed PQ to be half of BC. So students, pay attention. Opposite sides of the quadrilateral, PR and BC, are also equal to each other. Yes, PR and BC are also equal to each other. And we already know that from our construction, PQ is half of PR. Yes, students, we know that PQ is half of PR from construction. And if PR and BC are equal to each other, I can replace this PR with BC. So now I can say PQ is half of BC instead of half of PR. And there we have achieved the second part as well. Yes, students, I hope you have understood the midpoint theorem. It's an extremely important theorem and it's not at all difficult. What we have done is we have proven these two triangles congruent. Once the triangles are congruent, we take these two alternate angles and say they are congruent by CACT so that we get parallel lines. We get AP and RC parallel. Also, we say AP is congruent to RC so that we get PB and CR congruent. PBCR becomes a parallelogram, and then we use the property of opposite sides of a parallelogram are equal and parallel. Yes, so to summarize, this is exactly what we are doing in our midpoint theorem. I hope you have understood this theorem extremely well. This is an extremely important theorem. We'll be stopping here for today. All right, so I hope you enjoyed your lecture, and please make sure you revise this theorem well. In the next part, we're going to see converse of the midpoint theorem. We'll see how to prove the converse of the midpoint theorem. So I hope you enjoyed this lecture. Bye-bye for now. All right, yes, bye people. Yes, thank you so much. Yes, you're most welcome, everyone. All right, so I'll see you the next time. Okay, all right.